Okay, good afternoon, everybody. Thank you for hanging in all day. It's 6 o'clock over by you, but by me it is lunchtime. So okay, I will start sharing my screen. Okay. Okay. Again, thanks for taking the time out of your day to join this talk on getting started with the Jakarta NoSQL specification and the MongoDB database. My name is Michael Redlich, and this is my background. I work for ExxonMobil Research and Engineering. This is the petrochemical research organization in quotes. I've been with the company almost 33 years, but in my spare time, these are the things I like to do in the Java community. I've been writing for InfoQ since 2016. I am the founder and a co-director of the Garden State Java user group. That's the logo you see on the top right of your screen. I'm also on the leadership council of the Jakarta EE ambassadors since 2018. And then I'm a committer to the Jakarta NoSQL specification. And added to that list is also the new Jakarta data specification, which I'll tell you a little bit about near the end of this. So we have a lot to do. I'm going to go through the slides, and I have a working application that I'd like to demo. So the objectives for this particular talk is to, what is this Jakarta NoSQL? What is Eclipse JNoSQL? Quickly talk about the NoSQL database types, the different NoSQL layers. We'll do a demo, that's always fun. And then do some resources at the end and where you can find different things and how you can contribute if you'd like to do so. So, Jakarta NoSQL. It is a Jakarta EE specification of one of the 42 specifications that are part of Jakarta EE. The specification lead is Otavio Santana, who is actually speaking at JCON this week as well. So the intent of this is to streamline Java applications with NoSQL databases. And there are a set of APIs that in which you can implement for most of those databases. And you'll see a list of the databases that are supported. Also, too, you may see reference in the documentation that this is one API, many databases. This is very true. And Java user groups are encouraged to adopt Jakarta EE specification. We've done this with the Jakarta NoSQL specification. And at some point, I'm going to do the same for the new Jakarta data specification. So if you're part of a Java group, wherever you are, say you're the leader or you're somebody who would is part of that group, maybe you can encourage your leaders to do the same. Eclipse JNoSQL. One of the things that all these specifications have, whether it's Jakarta EE or MicroProfile or any of those others, is that you need a compatible implementation. And that's exactly what JNoSQL is for that. So the implementation, there is one API for each database type. We'll see that as we go along. And the annotations you would use, regardless of which database you're using, which NoSQL database you're using, are the same. So that's kind of the beauty behind this. There are 4 types of NoSQL databases, and you can see them listed right there. We'll talk about those individually. So it's the key value, the column family, the document, and graph. And MongoDB is a member of the document database family. NoSQL database type. Well, we'll start with key value. This is the simplest of all the NoSQL databases, and you can see the key and value right there. You can see Aphrodite points to 2 different values, love and beauty. you can get the value, your client code can get the value for any specific key. You can assign a value. You can do all these kinds of operations. The value can be a binary large object or a blob, or it could be anything really. So that's the intent of the key value database type. Because it's so simple, it offers excellent performance and can be easily scaled. Use cases for storing session data in a website, for example. You can maintain schemaless user profiles, storing user preferences, and some example databases in this particular database family are Redlich. I think a lot of people might be familiar with that. There's another one called MemCacheDB and another one called RIAC, R-I-A-K. So I haven't heard of those last two, but I have heard of Redlich. And this is a table to compare the relational database, such as MySQL, to the NoSQL type. Because something I learned first learning MongoDB is that there are, you can sort of equate them to a relational database. So I've done the same thing here with all these. So a table in a key value database is a bucket, and then the row is the key value pair itself. Secondly is the column family. And this is where data is stored in cells grouped in columns of data rather than rows. So it's obviously different, as you can see in the picture right here. And the columns themselves are grouped into column families. And the column families are groups of similar data that are usually accessed together. So you can see in this case, Apollo, his columns are duty and the sun, and so on, and you can see the other examples in that particular. The main advantage that column family has over a relational database management system is that it can do fast search and access and data aggregation. Use cases in something like this would be content management systems, blogging platforms, applications that require a lot of heavy write requests, such as log aggregators. You want to avoid using a database like this if there's complex queries that you will need to perform on your database itself. Example databases. This is are two very popular ones. They're both are Apache. It's Cassandra and Hadoop HBase. And here again is another comparison to relational databases here, though. So the column family itself is, is like the table, and then the column is the row, and a key value pair is the column itself. Next is the document database, and if anybody's worked with MongoDB, this should look very, very familiar. This is in JSON format, but more accurately, it is a binary JSON format in the database itself. So it's key value pairs, as in JSON. I'm sure everybody is familiar with that format. This is kind of similar to the key value. The value is structured. As I mentioned before, it's a binary JSON document. Again, you want to avoid this if you would like to, if you need complex querying in your application. And if you've ever worked with MongoDB and have done some querying, it is a bit tedious in terms of getting all the parentheses and everything else correct, and whether it does, like, for example, where it says name : Diana, they're both in quotes, but the key itself doesn't necessarily have to be in quotes, so things like this and getting everything lined up can be very tedious. I've tried doing a sort of a inner join, which is possible to do. It doesn't come out exactly the same as a relational database, but it can be done. But again, it just gets a little bit more complex. Use cases, e-commerce applications, content management systems, and of course, MongoDB is one example of a document database. Okay. And in here, this is the comparison. A table is in a relation database is a collection. So what you saw here is a collection. The row is the document itself, and then a key value pair is the column itself, like that. So, and it has this link relationship. And to be quite honest, I'm not exactly 100% sure what that really means. I should write that down and try to find that out for you. And last but not least is the graph database. And if you've ever taken graph theory in computer science classes, you know, this looks very familiar to you. Here's the relationship, you know, among the different, I'm going to call them nodes, just like in graph theory. So Apollo and Aries are nodes. And then you have these edges that defines that relationship. So it's, you know, Apollo and Aries are brothers. And, you know, Apollo knows Hephaestus, you know, and so on and so on. So, so that's the relationship on the graph theory. The graph database is built on top of the entity attribute value model. This encodes things in a space-efficient manner, where the entities or the attributes themselves that can be used to describe them is potentially, you know, huge, but the number will actually apply to a given entity is relatively modest. It's a flexible way to describe how data relates to other data. Nodes store the data about each entity, and relationships describe relationships between the nodes themselves. Use cases in a graph database is fraud detection, graph-based search, hence graph theory. Social networks tend to use this. And example database, which is very popular, is Neo4j. Also, there's ArongoDB and OrientDB, among others. So this is just a couple of examples of that. And then, just like in graph theory, there are vertices, there are edges, and so here's the relationship, you know, to a relational database itself right there. So pretty straightforward. All right, next are the two layers of Jakarta NoSQL. There is the communication layer and the mapping layer. And early on, these had the names of Diana and Artemis, which are, you know, Greek gods or goddesses, and then that eventually evolved. And the reason I mention that is because you may see some blog posts out there that still reference, you know, it might be an older blog post that still references those names. So sorry about that purple. I got to try to find an image that has, so you can see it more clearly. Doesn't show up too well in the black background. So, so in any event, so these are the layers and how they relate to each other. Right. So the mapping, communication, it's all part of the data access objects, DAO. And then, of course, you see the 4 different NoSQL databases in this particular relationship here. And then there's the data tier. In the communication layer, it is a set of APIs, and obviously, hence the name, it defines the communications with all the different database types. There is one set of classes, or, you know, for each type. So these are the modules that represent, you know, all 4 of them. And if you're familiar with JDBC, that's part of the, you know, the Java programming language, of course, then you can consider those the same kind of, you know, sign relationship there. The mapping layer, it has to do with mapping, you know, your objects in the database to objects in a Java application, right? And incorporates the Jakarta context and dependency injection and the Jakarta bean validation specifications. This is very annotation driven, as we'll see. You know, with the references to an ID in your database and to columns themselves. And we'll see that when we get to our example. And you can compare this to using the JPA, the Java Persistence API, formerly known as, which is now Jakarta Persistence. And then ORM, of course, object relational mapping, such as Hibernate, so this is how you can compare the mapping layer. So this just gives you an idea on scalability versus complexity. And if you look at this all makes sense, right? The key value is, hardly complex, but very scalable. And then you can see where the other three, fall into that graph right here. This is a comprehensive list of all the databases supported by Jakarta NoSQL. You see some of the ones that I've already highlighted, like Cassandra. CouchDB is another one. Tinkerpop. While I'm thinking of it, this has to do. I think this is the implementation for a graph database. So instead of reinventing the wheel, the Tinkerpop is used in that instead. So you see MongoDB, Solar, everything else. All right. This is the best part, right? So let's go. So let me set the stage here. All right. So I'm using IntelliJ IDE. We'll open those up. I have my Mongo daemon running, and I have my Compass application that connects to MongoDB databases. Of course, I could use the command line, but this is just more visually appealing. So in this beers database, and then by the way, I am a huge fan of or enthusiast of craft beer, so hence the intent of doing this. So you'll see that there are 22 different beers that I've had in there. There is an ABV or alcohol by value content. There's the name of the beer itself. There's the brewer ID, which corresponds to the brewer collection. And there is a beer type. So you can see ale on this one, IPA, and so on. In the brewer collection is the brewer name, the city and state in which it happens to be located. So you can see here some of my favorites here: Southern Tier, Dogfish Head, River Horse, and so on. And we're going to add to this database during our demo. I was trying to have the update portion done before this presentation. Unfortunately, I didn't get there. So, all right. So let's start here. First, let's start with some configuration. Microprofile config is used in Jakarta NoSQL. So if you're familiar with microprofile, there's a config specification that allows you to do relationships like this. So some of this stuff we don't necessarily need, but I'd like to show you exactly how you could do stuff like working with two different databases. So here's DB1, right? We'll just assign it the same name. So here's the database itself, beers database. Let me make this bigger. I'm thinking about it. Okay. All right. And you'll need, of course, the host information. So by default, MongoDB uses port 27017, and this is a reference to the MongoDB document configuration. Right? So you can imagine this being for another database, that kind of thing for your connection itself. All right, so we'll keep that open for a little bit. We'll start with the two POJOs. The first one is beer, and this obviously corresponds. This will correspond to our database. All right, and you'll notice here right away, you'll see the entity annotation. So this identifies that this is an entity. You have an ID. annotation that actually, obviously defines what the primary key is. And then each one of these is a column. And this is something you can do, by the way. You can actually have a reference to the actual column in the database itself. So brewer_ID corresponds to here. Oh, right there. So the brewer_ID is 12 in this particular case. Because what I'm going to use is brewer ID, typical of your beans, Java beans type of naming your variables. Okay. So it's not the end of the world if you mix these up. I believe I did that, and I believe it created another entry in the database. It was something to that effect, but it didn't blow up your application. So, and then here's the ABV, and then default constructor. So this is typical, typical Java stuff. All right. But they had these, here's the getters. So, and this is on my GitHub site, which you can, clone yourself and play around with it, make things break, send me an email saying, hey, Mike, this, you forgot to do this, please, and do that, by the way. If you find something that could use improving, that would be awesome. I'd appreciate it. All right, so you have all your getter methods, and then I have toString, of course, and then I have these builders that you can do. It's extra code, but I think it's kind of cool, So it's pretty straightforward. You define your builder with the same variables here. So we'll see how that's used. And similarly with the brewer, same thing, entity, ID, all that good stuff, right? So again, this is pretty straightforward. So, all right, so let's see, where do we want to go now? Let's go. So we have two different things. I have a beer repository and a beer service. You can use one or the other, but in this case, it doesn't hurt to use both. And the same thing for a brewer repository and a brewer service. So in the beer repository, what's kind of cool is this here is the specification actually implements this stuff in the background. So I have here a beer repository that extends the repository class, and I think it's it's an interface. Yeah, sorry. So extends that, and it accepts a type beer, right? And then also a string. So what you do is all you do is do your normal interface stuff, defining the methods. So here we have a find all. And here's a page all to do pagination, and you can see it's grayed out, so I have not used that in itself, and that's a thing, a to-do item, right? But then you have your normal find by type method. So find by name, find by brewer ID, all right? In this case, we're just going to pass the name of the beer and find by name, and then find by brewer ID, we're going to pass in the brewer ID, etc. And then there's a delete by ID. I do have it commented out in the main application to do just that. Okay. And the beer service is a little bit different. Okay. So in the beer service itself, we're actually going to inject the property, the database itself. So here's DB1 that referred to the microprofile config, all right? And then you have this instance of or store an instance of this template. So you have the methods. I just wanted to see something real quick. No. You have an insert method that would insert a beer into the database. So then basically you would just say template based on this right here, dot insert, and then the beer. Very, very straightforward. And then in find by name, takes a string, and then you use this document query. That's part of the NoSQL specification. And you do this very similar to SQL commands. So, you do a select from beer, okay, which is a capital B in this case, I believe. You can double check that. Yes, so it's capital B right here. Just got to check that sometimes, right? Where name is equal to the name that's being passed in here, and then you build that, and then you do your query itself. You return that in there. And similarly, find by brewer ID. Okay. You do the same thing. I do use a find by ABV. All right. So from beer.class, like get simple name, right? Where ABV is greater than. So in this case, I do show in the main application that anything above 8%, I think, is the threshold that I use. Okay. So that's the GT is greater than, and then you build that, and then you execute, and that's it for that. Oh, one thing I forgot to mention, this is used in building, it's in the POJOs themselves, is a enumeration of a beer type. And I have that separately. I'm going to make that bigger. It's not working with me. I hope you can see that here. So it's just a private, public enumeration beer type, and I have them all listed. And I just recently added ESB when I was kind of looking at this, an extra special bitter type. So anyway, but you can assign these, and you can see based on the fact that the syntax highlighting has ale, IPA, those are the only ones that I've been using at the moment. So, and then also similarly is the brewer repository. Again, you're just listing, defining, or just not defining, but just declaring your different methods. So in this case, we're going to have a find all, find by name, and delete by ID, and then update. And there's one thing I was just adding just more recently. And the same thing with service. And it's very, very straightforward. So I have about 15 minutes. So all right. There is a service. There is a service class here, which basically injects a beer repository and a brewer repository, and then you can just get those, and you'll see how that is used in the application. So here we have the main application. Now, it's on my list to actually have this as a nice, REST application. I tried my hand at it earlier this year, but I was failing miserably, so I just kept going to the system outs, and I can use logging as well, just as easily enough, right? So we'll go to the top, okay? So we're going to use a Java SE container for this, right? We create the new instance and then initialize it. Okay. So this is, just sort of the Java SE version of CDI, having a container. We'll use that instance of the container to select our service class, and we'll get that. So then we have an instance of service. And then our beer repository, right, is a service.get beer repository, and you saw that in the service class that I just showed. And it's just a empty parameter list. And similarly for, for brewer. It's kind of interesting. So you're using the repository, but you're using service to get the repository. So in this case, you can do instance of beer service using the container from here. Okay. So we get that and just pass in the beer service.class and similar brew service.class, etc. So the first thing I'm going to do in this application is get all the elements inside each of those collections. And then I'm going to use, from this, I will use the count method to get the number of beers in there, and then size. And then let's take a look. There are 22 beers and 28 brewers. So just keep that in mind for when we run this. All right. And then it's just system out stuff. Okay. So here we're going to create our first beer, our first brewer. And it's the Reddington Brewery, not too far from this site in Clinton, New Jersey. It just opened up last November. So of course, this is an opportunity to put this in the database, right? And it's just using the builder stuff that I defined, you know, .id, .name, and so on, and then build that. And then we use the save method to put that into our database. Similarly, and you know, I'm using the number of brewers +1 to add, and this way it just, you know, just increments to put those into the database. And similarly, there's a brewery in Kansas City, or one of the breweries in Kansas City, called Boulevard Brewing, which I can happily get here in New Jersey, and they have some nice varieties as well. So we'll put that in the database. But in this case, you notice we're using brewery repository.save, and then the name of the variable that I defined up here. And then the same thing with Boulevard, except we're using the brewer service, right? .insert, all right, and we'll put that name in there. So when we run this, right, we'll have 2 new brewers in the brewer collection. When you get a look at this, this was my attempt at using the template in the application itself. It wasn't working, so it's commented out for now. All right, so the first thing we'll do is let's get a brewer by name. Find by name. Now we're going to rely on the fact that our transactions were actually accepted into the database. So I'm going to do a find by name by Boulevard Brewing. Now, of course, it doesn't happen. Then it does throw a, in this case, it was, give me a second here, I have a catch. Yeah, a index out of bounds exception. So I do catch that. So I played with this earlier and added that in there. So, yeah. All right. Okay. All right. So we'll do that, and then we'll get the ID of that brewer. Okay. And then we'll put that out there. Now let's add 2 new beers. Now in this case, we're going to add 2 new beers from the brewer ID that we just accepted, or just happened to get. And we'll do the same thing here. Is using, well, it should say something different, but that's okay. It's just a variable name. We'll just add in the name of the variety by Boulevard Brewing called Tank 7. It has an ABV of 8.5. It is an ale. So that's where we define all that. All right. And then we'll save it. And then these variables were from the Alchemist Brewing. So, but anyway, it doesn't matter, right? As long as these match and it works. So, and then the second beer is the Calling IPA. And that is another one that is, actually that is 8.5, but might as well fix it here. Got to fix that earlier. And it's an IPA, no surprise. And then we'll use the insert again. So here's the beer repository version where we save, and then the beer service where we insert. Right? All right. So in this case, now we're going to exercise some other things in the database itself. So we're going to find by name pumpkin, and this is the Southern Tier variety. It's seasonal. It's out right now. If you know, from wherever you are, if you can get that, awesome. And then we're going to use the for each method to iterate through that, and it is going to only be 1 entry, but it's a, you know, it's a stream nonetheless, right? So it's one, you know. So we'll just do our simple lambda here, and then just, you know, here is the beer I found, and okay, checking the time here. Then here we want to find the varieties of beer offered by a brewer ID. All right. So in theory now, since we're still using the same brewer ID, which is our newly created or will be newly created entry into the database, it should put out those 2 particular beers. And you can of course play with this and, you know, try to put other stuff in there and all that good stuff. And I meant to take that out, because if you don't do this, this will give you the stream, like the address of it. So you don't want that as part of your output. So we'll fix that. And so forth there. And then you can find your brewers by city and state. So in this case, I'm passing in I have about 4 or 5 breweries from New Orleans, Louisiana. My wife and I visit there quite frequently. So there's a lot of great brewers out that way. If you're ever out there, ping me, I can tell you where to go. And then we'll do the same thing. Put that out there. And then as I mentioned earlier, I'd like to find beer that is greater than 8%. So you can do that here, pass in 8.0, and then do the same thing. This is a work in progress to do the updates. I'd like to just update the particular thing. So sometimes seasonal beers will be 8.5 one year, and maybe 7 the next, and so on. So, and then this is how you would delete. So this works, or you can explicitly put it in, that number, and I was cleaning up the database and using that. So you can uncomment all that for each of those. One's a brewer, one is the beer itself. Okay, well, let's see how this runs. Now, I didn't want to add stuff to the database when I was testing this morning. Of course, if I had normal tests, then that's something else I need to do. So let's clear this out first. Okay. So let's do an MVN clean compile, right? In theory, it should work. In practice, of course, doing a live demo, that's always a challenge. Okay, good. So, and I'm using, and this is where I think a REST app would be awesome, right? All right, so what I'm doing here is I'm using the Maven exec Java, and then -d exec main, and then the name. And I'm going to output this to a text file. This way it'll be a little easier to read once we run this whole thing. All right, so let's see. So I said 22 beers and 28 brewers, right? So let's run that. Okay, that's good. That's a good sign, at least, but I don't know for sure, right? So here's beers.text. Okay, you can just ignore half of this stuff already. There was some warnings, which I'll have to investigate at some point. All right, so originally it says 22 beers and then 28 brewers. So I actually should run that again later on. But we finding a beer by name. Here's Boulevard Brewing, which, okay, it worked, looked like it worked. And before we go further, let's do a refresh. And you'll see now there are 30 brewers, which should have our 2 new entries. So you'll see Reddington Brewery and Boulevard Brewing, right? And we should have 2 new beers. It would be 24 now, which makes sense, right? We had 22 earlier. And then the Tank 7 and Calling IBA. And then you'll see the brewer ID to which it corresponds, right? So, which is 30, which is the brewer right there. So let me double check that. Just to make sure. Yes, ID is 30. So cool. All right. One thing I do like to do, by the way, before we continue, is actually to programmatically do an inner join of some kind. I tried this with Python for a project here at work, but that didn't work. I was able to do it on the command line, but programmatically doing it with Python, and there's a MongoDB database, but it's not a beer one, of course. It has to do with my job, right? So anyway, but yeah, let's continue here. So this is something I'd like to see, like to try and add to this application. All right, so we found a brewer by name, and we passed in Boulevard Brewing, and it gave all the attributes in JSON format. And of course, our brewer ID was 30. All right, so adding 2 new beers, right? That's what we put out. All right, and then as I mentioned earlier, I put in a random variety here, and it found Pumpkin. And then these are the 2 that are found by brewer ID number 30, and then has both in there, has Tank 7, has the Calling IPA. And then you'll see, well, it might be 6 here, actually. These are the 1, 2, 3, 4, 5, 6. Yes. Yes. I've been to all of these, by the way, except for this last one. They just somehow eluded us. It's still in the city, but it's a little bit outside, but we will get there one day. Oh, and these are the These are the beers that have an alcohol by volume greater than 8%. And you can see those right there. And even our new ones, which were 8.5, are in there. Okay, and that's that. Okay. Let's see. I know we're holding questions to the end, so I'm going to return to. You only have about 5 minutes roughly left, but 5 minutes of this, and then maybe 5 minutes of quick Q&A. So, all right. So the current status of Jakarta NoSQL right now is still in development. It will not be part of Jakarta EE10, which is coming out tomorrow, I believe, for the GA version of 10. It's been on, Jakarta EE10's been being developed the last number of months. Ever since 9.1 came out last May of 2021, I should say. So at some point, this will get to the, where we're going to be part of the platform profile. So for, part of all that. So it's still in development. It's version 1, beta, B4. And then this should be upgraded. Yeah. So we have migrated to Java 11. I've been using Java 11 in this application. And I mentioned earlier this new specification called Jakarta Data, and basically it defines core APIs, right, for Jakarta EE that would allow applications and other Jakarta EE components to access data technologies such as relational and NoSQL databases and cloud-based data services. So more on that to come. We just got together as a team more recently. We started having meetings on this. The repo is brand new, and so on. So there'll be some work on this for quite some time. Here are some resources, and I have these slides, although an older version, it just has the better images, that you can use to get started. This was from 2019 when Jakarta NoSQL was, relatively getting started. One of the other InfoQ editors had written a news item on that. That YouTube link, I believe, was Otavio, either by himself or with someone else. I forget which. And then this is an older blog post by, I think his name is Eugene. It's baildung.com. And he uses the older references to Diana and Artemis because it's an older blog post. And how to get involved. If you're interested in getting involved, please contribute. Even though it doesn't have to be code, it could be documents, maybe some updates on that. And if you go through and read and say, oh, maybe this should be more clear, you can do that, right? And you can get started by forking the NoSQL repository under Eclipse-EE4J. And then there's another repository called JNoSQL, but I think that's just under Eclipse and not EE4J. So again, one's the implementation, one is the spec. And of course, I need to acknowledge Otavio. He's helped me through when I first started getting into this a little over a year ago, or even more than a year ago. And we've had a few Zoom meetings to, answer my questions and, help me get started. So it's great. So I forget what he's discussing this week, but, please listen to, go to his talks and you won't be disappointed. Contact info here. Obviously, that's my Twitter on the second line there. My main website. I have a portfolio endpoint, and my GitHub is mp-redlich01. So again, these will be on the slides themselves, and then you can take a look at all that on your own time. So I always like to end with this slide, even though I'd have to take the rest of the day off in order to have one of these. But where you are right now, obviously this at the end of the session for today, and I think there are 2 more days, right? So there's 4 questions. Let's see if I can even. My mouse is not working over this. Oh, I can probably do this. Hold on. There we go. There we go. Okay. So McAllis says, so the services are actually extensions of the repository for custom handling. Not quite sure. Not quite sure how to answer that. Extensions of the repository. I guess so. I guess, yeah, I guess because you're using the beer service, right, to define, the queries you'd like to do, or the updates, or the, any CRUD app, CRUD operations. I mean, I'll take a screenshot of that and I'll see if I can answer that better for you. So, let's see, any possibility that the database handles the generation of the ID? It did that automatically. Well, no, I didn't. I did define it, didn't I? Yeah, so if you, for example, so this would be something to test. If you wrote, there's a beer, and here it is. Okay. So yeah, I did explicitly define the ID right here. So I think DET, I did say that, all right? Explicitly say the new one, but if I left that blank, would it generate the new one next? And like something in MySQL, I know what happened. This is something definitely to test. If you want to take the time and clone my repository and get back to me on that, that would certainly appreciate it. Oh, okay. Okay. And then by the way, to execute custom queries, that's the need for implementing the service classes. Yes, and I think is that yeah, so what did we do here? Service was repository interface right here, right? Yeah, so the difference between the two, and I think I mentioned earlier, you can do either or of these. So in this case, with the repository, we're declaring methods, but the implementation is done by the, specification. But then in the service ones, we will actually have to define them. And I think you can probably, do one or the other, and and go from there. So yes, I believe that is the case. So, okay, so let's see. This is all a great initiative for Jakarta. Yep, using MongoDB in the past. Yeah, thank you. Thanks for that comment. Yes, it's I just want to take a minute here to say, a lot of people, maybe not so much these days, but a lot of people would say that Java itself, the programming language, is dead. And you could probably argue that back in 2000, let's say 2017, was it 2016, when Java EE was finally released, or Java EE 8, I should say, probably 2016. So Java EE 8 was being delayed. Oracle was putting it out, right? And they finally put it out. I want to say it's 2017. Yes, that's what it is. But in the meantime, you had organizations that showed up in 2016, like Microprofile, and what was known as the Java EE Guardians, is to sort of sort of get Java into this microservices space. And then when Java EE was released in 2017, Oracle donated it to the Eclipse Foundation, which, long story short, evolved to the new name of Jakarta EE. So in case anybody wasn't aware of that, that's what happened. So Jakarta, is all open source, where the Java EE or the enterprise was closed source. That's the big difference between the two. And now I think this is an exciting time. Because there's a lot of development in the microprofile area. Version 6 is supposed to come out next week. I'm sorry, next month in October at some point. Jakarta EE 10 is coming out, tomorrow from what I've seen. So yeah, it's I think there's a lot of great work. There are so many specifications to make things easier. This is sort of a long-winded, explanation for what you said at the end here about having to do things a little more complicated, right? So yes, this was, this is something that I have a passion for doing and continue doing. And as I mentioned before, I've been with Exxon for 33 years. I am planning on retiring in the next year or so, but I'm not going to retire from the Java community. I'll keep working, on my own for different things. So anyway, all that, thank you very much again for coming. And look at that, it made it in 50 minutes. Perfect. So enjoy the rest of the conference today, tomorrow and Friday. And, hit me up, send me email, whatever, play around with the application, make it break. And, I would appreciate any comments. Thanks a bunch.